Awesome. All right. We are live. Cool. All right. So sorry for wasting your time. I had some technical difficulties with my streaming software, but it seems like we are actually live right now. So what I wanted to do, first of all, is give you guys kind of a short introduction to the tool that we created, which we call Boot, and to give you a high-level overview of why we wrote it, why we're using it, and why we think that other people should be interested in also using it, especially if they want other people to integrate into their own code or into their own project. Yeah, let's get started. I have a small presentation. So, high-level overview of what I will be talking about. I will talk about interacting with CosmWasm, how you can do it, what people are currently using to do it, why you should use Boot, some use cases for Boot, and then I will demo it by updating some of the code that we currently have for interacting with CosmWasm Plus smart contracts, and showing you how you can basically use Boot in your own library in your own code to ease your testing and deployments and to save everybody's time. So let's get into it. So CosmWasm Interactions. Interacting with CosmWasm contracts is time consuming. So a lot of interactions that you do with your smart contracts are going to be either through a CLI. If you're interacting with your smart contract on a real blockchain, you're going to be interacting with it over a CLI, which is kind of a pain in the ass in my opinion. You can use it through a front end, something like Juno tools, where you can drag and drop your smart contract WASM file into it and then write your JSON messages that you want to execute. Or for bigger projects, you would use Python or JavaScript scripts in order to deploy your smart contracts, to instantiate them, etc. Let me check real quick. Yeah. And on the other hand, when you're testing your smart contract, you will probably be using CosmWasm multitest for your integration testing, which you do in the Rust language. So some examples. These are some code snippets from Astroport. So on the left, it's their main function that they call when they deploy their contract to a blockchain, and on the right you can see some code that they use to instantiate their contracts on a multi-test environment, on an integration test environment. And my point being that both these softwares, all this code that they wrote, basically is used to deploy their application, deploy Astroport to an environment. But functionally, there is a lot of code that is identical between the two. And that means that, first of all, setting up these two deployments in these two different languages is very time consuming, but it also means that when you're iterating on your product and things change, that you have to change them in multiple places, which is, again, not very efficient. So why would you use Boot? Well, because CosmWasm's actor model defines a very specific interface to your contract in terms of the message struct that you define for your smart contract. And by keeping your interactions closely aligned with these message structs, you reduce the cognitive and technical overhead that is required to interact with your smart contract. So the goal of Boot is to unify CosmWasm interactions. And how do we kind of do that? We define the entry points to the smart contract, which you already have, that's already available. And we take the WASM code, or the entry points of the smart contracts, which are a set of functions, and we bind them to a virtual contract. And this virtual contract is what you will be interacting with. And then you can pass in an environment to the virtual contract, and the functions that you wrote for the virtual contract, the interactions that you call on the virtual contract, they are generic over the environment that CosmWasm contracts can be deployed on. So currently we have support for the CosmWasm testing framework, and also for executing smart contract interactions on a blockchain node. But in the future, we could support other types of virtual machines. We could support an interchain infrastructure where we do IBC calls on the smart contracts, and it can be generic. So you write your deployment once, and then you just pass in the environment, and it deploys on that specific environment. So the advantage of that is that deployment code can be reused, of course. Other environments, like I just mentioned, can easily be added and supported. And these virtual contracts, they can be packaged and then shared with other developers, enabling everyone to easily deploy and interact with the application that you wrote. And this is a very integral part of why we really need something like this, is because Abstract, that's the product that we're building, is a framework for building smart contracts, and we want other developers to easily be able to use our framework to test their own smart contracts with our framework, and there wasn't really any tool out there to do something like that. On the other hand, we see this being useful for things like DEXs. So we have had a bit of trouble integrating some DEXs into our framework, and that is why I created this repository, which you can find on our GitHub, and it currently holds an integration for Windex, and that means that any applications who use Abstract and who want to also use Windex can easily import the Windex struct, deploy it on their environment, in this case a mock environment, and then they have like some pools instantiated, they have the factory instantiated, so they can create their own pools if they want, and it's all very accessible to them. So in comparison to other tools that one might use, Boot has really clean syntax, just like Beaker, which is a tool provided by Osmosis Labs. Bash syntax, I wouldn't really call that clean. Contract deployments, so can be done with all three of them. Boot is Rust native, which means that when you update your smart contract code, the code that you use to test and deploy your application will also break, and it will tell you, it will keep you up to date, basically, which is very easy. We have support for CW multitest, as I already mentioned, and the code that you write with Boot is shareable, which enables anyone to use your contract. So what I'm now going to do is I'm going to jump into the docs real quick that we have for Boot. So these docs are available at, let me zoom in real quick. So the docs are available at boot.abstract.money. Put that in the chat. boot.abstract.money. And they guide you through some of the IDs and how you can set up boot with your own smart contracts. So we'll go over all these little steps in the demo. Then there's also the repository that you can check out, which contains also some information. If you want to contribute, feel free to open an issue, open a PR. We are very welcoming of any people that contribute. So then I think it's time that we go into some of the code. If you have questions, by the way, yeah, I'll zoom in more. If you have questions, feel free to put them in the chat, and I will read them and try to answer them. Cool. So I am now in the boot repository. And we already have a package that's called boot CW+. And the idea is that we want to provide the boot interfaces to CosmWasm Plus, just like we are just like we do for Windex, for example. But this hasn't been updated in a while. So what we're going to do is we're gonna update this CW20 contract to be the actual CW20 base contract, and then we're gonna just talk about the function derive macro that we have written, which will make this a lot easier to use, and which requires us actually forking CW+. So maybe let's start with the struct. So the idea is that you create a struct, which I previously called the virtual contract, and you add a derive macro on top, where you define the messages of the struct. And you see here that they are imported from CW20 base, and this macro derives a set of traits on the CW20 struct, and that allows it to be used as a contract. So then we implement a new function for the CW20 struct. This is chain generic. So a CosmWasm environment, Rust analyzer is not it's not liking this. Plus boot whatever. Let me fix that real quick. Awesome. Yes, so where were we? This CW20 contract. So here we define a generic. So we say that the CW20 contract, or the CW20 base contract, is generic over any chain that implements CWEnv. And I think I should probably try to reload because Rust Analyzer is not working with me. Then we add a new function that takes in a generic chain, and this path is a cargo manifest directory. So this basically points to the this path, and then we use the CW artifacts in here so that we can easily export this as a package and include the WASM files. Then in the constructor, we create a contract new, which is part of boot, and we I don't know why I can't click through. Super annoying. Okay, so this creates a contract new with a certain ID. Yeah, live demo fun, I know, right? And we add the WASM path. So this enables the contract to be uploaded, right? Because this this contract wrapper defined by CW multi-test is pointing to the function handlers of the CW20 base, and the WASM path is pointing to the WASM file that we created, that we compiled, or that actually Confio releases with every release of CosmWasm. And yeah, and here we have implementations for the functions that can be called on the CW20 contract, where self, so this CW20 contract you can execute on it, you can query on it. Oh my god, why the fuck? I'm so fucking confused right now. Rust Analyzer, please work. I'm going to delete this extension. CosmWasm. I don't know why why these functions aren't clicking through, and it's absolutely annoying. I'm gonna try to remove CW plus from my workspace and just open the folder actually. It's hilarious. Don't save. Cool. Let's see. Yes. So self.execute is still not working. Cargo clean, yeah, I guess. It's gonna take a while. Anyway, so you can execute, you can instantiate. So this is showing the execute. This is showing the instantiate, and the nice thing is that you just provide the actual message that you also use for your Rust contract, and then provide it to the function handler, or like to the endpoint on your contract. Cool. So instead of doing this, and instead of writing all these functions yourself, what you can actually do is you can use a macro that we wrote to make this job a lot easier for you. So what I'm going to do is I'm going to go to a new window, open folder, going to programming, and then CW plus. Cool. And now that we're in CW plus, what we want to do is we want to add our macro to the message structs of the contract, and I will explain what happens when you add that macro. But first of all, let's add the dependency in the cargo.toml. Or yeah, we can do it in the package itself. So for the CW20 base, if you go to message.rs, you will notice that there is no execute message in here, which is because this base uses the standard, which is CW20, which actually has the execute message in here. So what we then want to do is we want to import boot core, let's say version equals 0.9.0. So that's the latest version. And then in the message, we want to use boot core contract. No, we want to use boot core which was it again? It's like execute functions. Let me check. So boot functions derive, execute functions, execute functions derive, boot execute. Nope. Oh my god. What is it? Functions. Oh, it's like, I'm gonna have to look this up. In the documentation right here, it's derive. So, yes, yeah, okay, that makes sense. Because this is a derive macro. So, yes, execute functions. So this will create functions that we can call on the object that we use this, on the virtual contract that we use the CW20 execute message for. So I will do this for the CW20 execute message, and then I will do the same for the CW20 base query message, because we have a similar derived macro for that. So boot core equals 0.9.0, and then in the messages we can go to the query message. And the nice thing about the query functions macro is that it uses the same returns attribute as the query responses macro from CosmWasm to automatically derive what kind of return type is returned when you query a contract. So if we now just try to push this, git add git commit message, messages, and push it. Cool. So we pushed to this directory. Then if we go into our repository here, instead of all this garbage and this garbage, ingress, allowance, balance, transfer, send, we no longer need all these functions in here. What we can do is we can change the imports for this to use our repository that we have in Abstract.os. So if you go to Abstract.os, so we have a plus where we just pushed, and we use our URL. We can do this and do the same here. Cool. This builds. Then we can actually try and make a function here, pop function send, for example, on the CW20, and this will return a transaction result. For fuck's sake. Or not. Self.send. We first, of course, need to import the trait that was generated. So there is a trait that you see here, execute message functions, that was generated for the query message, and then the same happens for the execute message. So this is execute message functions, let's see, 20 execute. Oh, this is still using the old one. Cargo update. Let's see. Did we actually save this? Yes, we did. Anyway, can show it with the query. Self.balance. Right, let me try to figure this out. So it says the message exists, but it doesn't satisfy boot query. CO20 base query message. Query message, CLV20 base. Git checkouts. Let's have a look. Is in here. Self dot come on, sir. Balance. Okay, anyway, this is hella weird. Following trait must be implemented. BitQuery. Oh. Okay. CLV20 base depends on CLV20 core. So it has the derive macro, and this should generate the functions to retrieve, to perform the query. And this compiles completely. Compile, yes. It. Right. This is weird. What I can do is I can show you how we use it in abstract code, because I don't know why this isn't working right now. So let's go to the abstract repository. Cool. So in abstract, we use these kinds of macros to interact with our contracts very easily. So for example, we have a contract that we call the manager, and in the manager, we add this macro that I just showed off when we enable a boot feature, and that enables us to interact with the contract with ease. So if I now go to the tests for this contract, where we, for example, do upgrades, you can see that there is this, this function manager. these are all manual ones. Great. Yes, so this one, for example. So we upgrade a module on the manager, and this function is leads back to the struct, to the enum of the execute message, and it's automatically generated this function to interact with the manager after setting up the test environment. So maybe something else that I could go over is to show you how to set up the environment to actually interact with the contract. So I can go to boot. This. Go to our examples that we have up here, and this is a runnable example that we have. I can go to Gino, c.gino, cool, and I can run docker compose up. Nope. Oh, this is wrong. Gino, what do we have? Nodes. Docker compose up. I need to have Docker running, of course. And what we do is we, first of all, instantiate a runtime. So this is a binary script that we can run to deploy the CW20 to a blockchain node. And also, in the same binary, we instantiate a mock environment that we use to also deploy the application on. So Docker is starting up. And what we first do is we create a runtime, and this runtime is used by the Docker code to interact with the Docker daemon. In this case, it will be local Juno. And it needs this runtime because those actions are asynchronous and they use gRPC. We can get the network from a network configuration that is in boot core, where we have a bunch of networks in the daemon. We have a bunch of networks with different network configurations. And so you don't have to create these yourself. Then there is this daemon option builder that you can provide the network to, or a chain data, which you can fetch from the chain registry. And you can add an optional deployment ID, which will be used to store the deployment data of your actions in a local JSON file. You can instantiate the daemon environment with a simple function, and then create a token, upload the token, and do the same for the mock environment, which will return also like a chain object. But yeah, so let's try run this. Compose up. That's that. Let's cd into boot core. So cargo run dash example CW20, and we need to enable the daemon feature for that. And this will compile our code, and I hope that my test account, or like my local Juno account, is properly set up. So this is building blocks. of course, CO20 base, change this. Connection testing, config local Geno. So this is because this local Geno variable is different from what it expects. So local Geno, video local Geno, apparently minus testing. Et voila, yes. So what this is printing is that it found one gRPC endpoint. It is opening a daemon state object. Whoop. I should change. So you can change the printing sensitivity in the .env file. So it's currently on debug, but that's quite a lot of information, so we can change it to info. The daemon state file is also an environment variable. If it can't find it, it will create one. And then you can put your mnemonics in here. So there could be better support for things like a proper key manager that lives on your operating system. But for now, we just don't have the bandwidth to implement something like that. So let's rerun this with the new log information. So now we can see that we're opening daemon state. We're interacting with the testing chain using the address, and this is the address of the mnemonic that's currently being used, which is its test mnemonic. We are uploading this contract, the CW plus CW20 base. We uploaded it, get the transaction hash, get the code ID, and then this bottom print is doing the same thing, but instead of performing it on a real blockchain, it's doing it on the mock environment. So in here, in the CW20RS, maybe now it wants to work with me. If I import use CW20, I will need to so most of the time you also want to re-export these functions in your thing. So you do pub use CW20 so that I execute functions. Will this recognize it? Nope. Pub use CW20 base messages and then the query functions as CW20 query functions. Now we can import this in our example. Boot CW plus and re-export that as well in here. Just like that. And now if you compile it, and this should balance. Let's try that. This won't work, of course. Nope. Okay, it's still puking. That will be for after the live stream. But yeah, this is kind of how we how we use the setup. And then once you have created your interfaces, so the CW20 base contract, for example, or a CW1, we can actually create a new wrapper around all those contracts. So we will create a new file, we'll call this CW+.rs, and we can add this, and then pub struct CW plus, yes, and GitHub already knows what I want to do. And now we can implement another trait that's provided by boot, that's called deploy. So in boot core source, you have this deploy trait, and the idea of this deploy trait is that you implement this on the on a wrapper type that wraps all your smart contracts that you deploy to your either your testing environment or like a real blockchain, and you implement this trait on that wrapper type to fully deploy or to load the smart contracts from your deployment. So we can do the same with CW plus. So we will import these, and then we will do we'll import this trait, can't find trait, so this should be boot core. Cool. Then we can implement chain CL plus new, yes, but not really. We can implement deploy for my contract. Oh, oops. VS Code is not liking me today at all. And so the deployment, as you notice, is also generic over the environment. So this boot error, no actions to boot error, sure. Okay. Let's see here. Voila. Mute. So in this case, when we deploy CW20 to either a mock chain or a real chain, we only really want to upload the smart contracts, and we don't necessarily need to instantiate a version of that smart contract. But in your case, that might be the case. Yeah, you might need to like do CW20 dot instantiate, and really don't know why Rust Analyzer is being so annoying today. But this deploy trait is that can then be used by other people to deploy the CW plus repository and CW plus contracts in their own environment without them having to specifically take on a dependency on the CW plus repository and on the different types of the different contracts in the CW plus repository that they want to use. So I think this is kind of everything that I wanted to talk about. It's really sad that the derive macros don't seem to work, because there is another really handy derive macro addition, I would say, that allows you to make the action payable. So currently, if when with these messages that are generated, they don't have a coin field. So if you want to pay with the message, what you can do is you can add an attribute before. For example, if you want someone to be able to pay with a native coin, you can add a payable. CW boot core payable. Or not. Well, yeah, just payable. And then for this function that will be generated, it will be CW 20 dot burn, and then the amount, which would be like 100, and then it will require a vector of coins to pay for the transaction. So yeah, that's just a little note. It's also in the docs. If there are any other questions or things that you have, feel free to ask them right now in the chat. And yeah, I hope you enjoyed my explanation. I hope that my next live stream will have less technical difficulties, and I wish you a great weekend.